Hello. In this video, I'm showing you applications of linear equations in slope-intercept form to real situations, to real-life situations. So here's the first problem on page 316. We are going to write an equation that describes the situation and answer the question. So Cesar is renting an LCD projector. The rental company charges a $10 flat fee for administrative costs, plus $18 per day for the projector. If Cesar had a bill of $82, how many days did he keep the projector? Okay, so we know that the company charges a $10 flat fee. So he has to pay that fee, even if he returns the projector the same day, and $18 per day for the projector. So for 1 day, it's $18. For 2 days, $36. For 3 days is $54, and so on. So if Cesar had the bill of $82, how many days did he keep the projector? We're going to call y. The variable y is going to be the cost of renting the projector. Let y be the cost. And we are going to let x be the number of days he kept the projector. So those are the number of days he kept the projector. So y is going to be the $10, the $10 flat fee. And the days he kept the projector, so 1 day is going to be $18. So 1 day is going to be 18 times 1, 2 days is 18 times 2, 3 days is 18 times 3, and so on. We're going to call that 10 plus 18x. So that's the equation. And then if Cesar had a bill of $82, how many days did he keep the projector? We need to solve um, 10 plus 18x equals 82. So we're going to solve this for x. And that's a linear equation in one variable. We can subtract 10 from both sides or pass the 10 to the other side with negative sign. 82 minus 10 is 72. And then divide both sides by 18 or pass the 18 to the other side dividing. And 72 over 18 is 4. So that's the final answer. Cesar kept the projector for 4 days. For 4 days. Okay, that's one example. In the other example, we're going to determine the equation from a graph. In number, we're going to do number 61. So I'll copy the situation and the graph that we need. So this on the next page. 317. The higher education price index graphs show the changes in college faculty and administrative salaries between 2004 and 2019 using a base year of 1983. For example, an index of 240.7 for faculty salaries in 2005 would mean that the college faculty salaries in 2005 were 240.7% of what college faculty salaries were in 1983. So that's similar to the CPI, but that's only for higher education. and we can see a couple of line segments. So we can see the graph, how this index has increased for administrative salaries and for faculty salaries. So we're doing number 61. So we are going to find the slope of the blue line representing the change in the index for faculty salaries. And treating 2004 as year zero, write the equation of the line representing the change in the faculty salaries index in slope-intercept form. So we treat 2004 as year zero, and we have 2 points. We have the point 0, 234.2. And 2019, that's 15 years later, that's 15, 342.2. Now, if you want, you can use the points 2004, 234.2, and 2019, and 342.2, and you're going to get the same slope. So let's find the slope. The slope is denoted with the letter M, and is the rise over the run. That is the change in Y over the change in X. This 342.2 minus 234.2 over 15 minus 0. So 342.2 minus 234.2, that's, so let's calculate that. This is 108. 15 minus 0 is 15, so 108 over 15. And this is 7.2. So that's the slope. Now, the slope tells you the following, tells you that on average, the index increased by 7.2 points per year. On average, the higher education price index increased by 7.2 points per year between 2004, 2019. And then treating 2004 as year zero, write the equation of the line representing the change in the faculty salary index in slope-intercept form. So we found the slope, that's 7.2. And in this context, the y-intercept is 0, 234.2. So the equation of the line is going to be 7.2x plus 234.2. Okay, so that's the second example, and I'll do one more example about comparing food plans. College students can purchase points that can be used in the food service areas instead of cash. If you initially pay the basic food service fee of $35, then points can be purchased for 23 cents each. Otherwise, points cost 30 cents each. How many points must you use for it to be cheaper to pay the basic food service fee? So we're going to compare the plans. So we have, let's see. So I'm going to call them Plan 1 and Plan 2. So in the first plan, you have a basic food service fee of $35. Then points can be purchased for 23 cents each. Otherwise, points cost 30 cents each. Okay, so you have an initial fee, basic fee of $35, and points, which cost 23 cents each. And the second plan, there is no basic fee. You just purchase points, 30 cents each. So we are going to write a linear equation in slope-intercept form for each plan. So the equation for plan one, and we're going to give names to variables. We're going to let x be the points purchased, and y be the cost. So let x be the number of points purchased, and let y be the amount paid. Okay, so the equation for the first plan is going to be y equals the basic fee that students had to pay no matter how many points they purchased, plus 0.23 x. And for plan two, there is no basic fee, and points cost 30 cents each. So initially, it is better to purchase plan two, but at some point, it's going to be better for people who go often to the who often use the food services. It's going to be more convenient to use plan one. If they go, let's say, every day or 4 days a week, it's going to be more convenient to use plan one. So what do we have? We have two equations. I don't know at which point they intersect, but we're going to find out. Okay, so we know the y-intercept of the first line of the line for plan one is 35, and the other one is at the origin. And equation for plan two has a steeper slope, or has a larger slope, so the line is going to be steeper. And for plan two, so this plan two and plan one, the slope is positive and smaller, so the line is going to be flatter. And we want to find this point where they intersect. So after this point, it's going to be more convenient to have plan one. Otherwise, at the left of this value, it's more convenient to have plan two. So to solve that, we are going to solve. We're going to make the y's equal to each other. So solve 0.30x equals 0.23x plus 35. And we can subtract 0.23x from both sides, or simply move the 0.23x to the left with opposite sign. So 0.30x minus 0.23x is 0.07x. And x, divide both sides by 0.07, so x, it's 35 over 0.07, which is going to be 500. So answering the question of the problem, you must use at least 500 points for it to be cheaper to pay the basic food service fee. So you must purchase more than 500 points for it to be cheaper to pay the basic food service fee. Okay, thank you for listening.